Welcome back to another episode of our Amazon ECS video series. In our last video, we went through ECS tasks in detail and deployed a sample Nginx task on EC2. In this video, we'll take a closer look at the ECS service, the core feature that ensures your containerized applications stay up and running. We'll explore what an ECS service is, what it does, and why it's a vital part of managing applications in production. Alright, now let's talk about what an ECS service really is. In ECS, a service represents a long-running, stateless application. Its main job is to ensure that the desired number of tasks, based on your task definition, are always running and healthy. If any task fails or stops unexpectedly, the service automatically replaces it, helping you maintain high availability and resilience for your application. Let's break down what an ECS service really does for you. The ECS service acts as a controller that continuously runs your application based on the task definition. It ensures containers are launched and maintained exactly as specified. It ensures the desired number of task replicas are always running. If you tell ECS you want 3 copies of your app running, the service makes sure 3 tasks are always up. It automatically restarts failed or stopped tasks. No need for manual monitoring. If a task crashes, ECS detects it and replaces it instantly. This ensures high availability and reliability. Supports load balancing. ECS service can hook into application load balancers or network load balancers to route traffic across all healthy tasks. This helps distribute user traffic evenly and improves performance. ECS service enables zero downtime deployments through rolling updates. It gradually replaces old tasks with new ones, ensuring your application stays available throughout the process. ECS service are flexible. They can run your containers on Amazon EC2, AWS Fargate, or even on your own servers using ECS Anywhere. To better understand ECS service, let's stick with our office analogy. As we discussed earlier, if an ECS task is like an employee doing the job, then the ECS service is like the manager, making sure tasks are running, managing them, and keeping everything running smoothly. The manager's first responsibility is to ensure the right number of employees are always present and working. If someone quits, the manager finds a replacement immediately, just like ECS replaces failed or stopped tasks automatically. If an employee's role needs to change, like updating responsibilities or tools, the manager doesn't switch everyone at once. Instead, they gradually roll out the change while keeping the office running. That's like an ECS rolling update. When work piles up, the manager distributes tasks evenly across available employees to keep things balanced, just like ECS load balances traffic across running tasks. And the manager monitors each employee's performance, making sure they're productive and everything is working as expected. That's where CloudWatch monitoring fits in. So, ECS service is like an office manager that keeps tasks running smoothly, efficiently, and without interruption. Now, let's talk about why an ECS service is so important. First, it keeps your application running by making sure the desired number of tasks are always up, even if something crashes. If a task fails or stops unexpectedly, ECS will automatically replace it. No manual action needed. It also distributes traffic evenly across all healthy tasks, using an application load balancer or a network load balancer, which improves both performance and reliability. When you deploy a new version, ECS performs a rolling update, gradually replacing old tasks with new ones, so your app stays available the entire time. You can easily scale up or down based on traffic. ECS takes care of adding or removing tasks for you, without disruption. And with CloudWatch integration, you can monitor task health and performance, making it easier to detect and troubleshoot any issues. In short, ECS service turns your containers into a highly available, self-healing, scalable application, with minimal effort on your part. Alright, let's jump into the hands-on part, and create our first ECS service. Alright, let's head over to the ECS console and open up our ECS cluster. Now, there are 2 ways you can create an ECS service. Option 1. You can create a service directly from the ECS cluster page. Just go to the Services tab, and from there, click Create to launch a new ECS service. Option 2. Alternatively, you can create a service right from the Task Definitions page. To do that, click on Task Definitions in the sidebar, then choose the task definition we created earlier. Select the latest version, in this case, that's version 1. Now, from the Deploy drop-down at the top right, choose Create Service. So, let's go ahead and use this method to create our first ECS service. Task Definition Family tells ECS which task definition to use when launching tasks for this service. Since we're creating the service directly from the task definition itself, it's already selected and locked, so you won't need to make any changes here. The task definition revision defines the specific version of the task definition to be used when launching tasks. ECS automatically selects the latest revision, ensuring you're using the most up-to-date configuration. However, if needed, you can manually choose an earlier revision. For example, you might pick an older version if you need to roll back to a stable setup. But in most cases, it's best to stick with the latest version. Give your service a meaningful and unique name within this ECS cluster, so it's easy to identify later. Under the Environment Configuration section, you'll choose which ECS cluster this service should belong to. Since we only have one cluster, it's selected by default. Compute options define where and how your tasks should run. There are two main options. First, the capacity provider strategy. Second, the launch type. When you select launch type, you get three choices: Fargate, EC2, and external. Since I covered these details in the previous video, I won't repeat them here. We'll also dive deeper into these when we talk about ECS autoscaling in a future video. So, for this setup, I will go with the EC2 launch type. Under Deployment Configuration, the Service Type option determines how the scheduler places tasks in your cluster. The scheduler ensures your scheduling strategy is followed, and if a task fails, it automatically reschedules it. There are two main service types, Replica and Daemon. With the Replica type, the scheduler places and maintains the number of tasks you specify, spreading them across your cluster and availability zones by default. With the Daemon type, the scheduler places exactly one task on each active container instance that meets your placement rules. For this video, I'll stick with the default and choose the Replica type. The Desired Tasks option lets you set how many tasks you want running. This only applies when you choose the Replica strategy. For this video, I'll set the desired task count to 1. We'll leave the rest of the settings at their default values, since we won't need to change them in this video. But let's quickly review those options so you're familiar with them. Availability zone rebalancing helps your application stay highly available. We recommend running your multitask services across multiple availability zones. When you turn it on, Amazon ECS automatically detects if tasks are unevenly distributed across availability zones. If it finds an imbalance, it redistributes tasks evenly to keep everything balanced and reliable. Health check grace period is the time, in seconds, that the service scheduler waits before it starts monitoring the health of a new task. This is important because some applications take time to fully start and become healthy. If you don't set a health check grace period, ECS immediately starts monitoring health checks as soon as the task launches and may mistakenly mark the task as unhealthy and try to replace it. By setting a proper health check grace period, you give your application enough time to initialize and pass its health checks before ECS begins monitoring its health. This helps avoid unnecessary task restarts and keeps your application stable. Deployment options and deployment failure detection will be discussed in a future video. Service Connect makes it easy for your ECS services to talk to each other using simple names and standard ports. We'll cover this in more detail in a future video. Service Discovery lets your ECS service be found using DNS names. It uses Amazon Route 53 to create a namespace, so other services can easily locate and connect to it. You can use Amazon Elastic Load Balancing to automatically spread incoming traffic across all healthy tasks in your ECS service. This helps improve availability and ensures no single task gets overloaded. Amazon VPC Lattice is a fully managed networking service that helps ECS users securely connect, monitor, and control traffic between services, even across different VPCs or AWS accounts. Best part? You don't need to change your application code. Service auto-scaling automatically increases or decreases the number of running tasks based on CloudWatch alarms. This helps your application handle traffic changes efficiently, scaling out when demand spikes and scaling in to save resources. You can update these settings anytime as your needs change. In the task placement section, you define how Amazon ECS should distribute tasks across the instances in your cluster. Several strategies are available in the drop-down menu. We'll dive deeper into these when we cover ECS scheduling strategies in a future video. In the volume section, you can define data volumes that Amazon ECS will create and attach to your tasks. These volumes are useful for storing persistent or shared data between containers. Tags let you assign key-value pairs to your ECS resources, making it easier to organize, identify, and manage them. In this setup, I'll enable the Propagate Tags from Task Definition option to automatically carry tags from the task definition to the tasks it creates. With all these configurations in place, let's go ahead and create our first ECS service. Once the service is successfully created, you'll see it listed as active under the Services tab. Next, navigate to the Tasks tab, and you'll notice that a new task has been launched by the service and is now in the running state. Click on the task, grab the public IP address, and open it in your browser. If everything is working correctly, you should see the Nginx default home page, which confirms that our Docker image is running successfully on ECS. Now, let's go back to the ECS console. We'll try stopping the newly created task to see if ECS automatically spins up a replacement for us. Select the task and click Stop. After a few seconds, you'll notice that ECS automatically launches a new task to maintain the desired count. This is the core behavior of ECS services. Since we're using the EC2 launch type with only one instance, the public IP address remains the same, even when a new task is created, because we're still accessing the public IP of the EC2 instance, not the task itself. However, if we were using the Fargate launch type, the public IP would change each time a new task is created, since Fargate provides a separate infrastructure for each task. Let me stop the new task once again to simulate this behavior, and you'll see ECS immediately replace it with another. Now let's take a look at how to stop ECS from automatically spinning up tasks again. To do this, head over to the Service tab, select your service, and click Update. Scroll down to the Deployment Configuration section and set the desired task count to 0. Save your changes. Once saved, you'll notice the running task has stopped, and the Nginx home page is no longer accessible, because no tasks are running anymore. And that's it for ECS services. Now you should have a solid understanding of the 4 main building blocks in ECS. In the next video, we'll manually launch an Nginx task using Fargate, and then deploy it through an ECS service, so you can see how this works in a serverless environment without EC2. So, that's the end of this video. Thanks for watching. Don't forget to like and subscribe, and I'll see you in the next video.